Good afternoon, students. Am I audible and whether my screen is visible to you? Hello, guys. Am I audible?
Yes, sir, you're audible.
Sir, yes, sir, audible.
Okay. Thank you, guys. So, guys, last class we discussed about the fuel injection system, and we discussed a lot of fuel injectors, how the fuel injectors are used in IC engines, both petrol and diesels. So we have discussed the single point fuel injection system and multi-point fuel injection systems, and we have also discussed about the fuel injectors and in fuel injectors, how the fuel injector is a normal fuel injector is different from the electronically controlled fuel injectors. So what is the device is going to control all the actuators and sensors. So this is what we discussed in the previous class. Okay, now let us enter into the topic. So the ECU. So the ECU is one of the important Okay, guys, let us enter into the topic ECU or electronic control unit or electronic control module. Because this is one of the most important parts or device in all the cars and all the automotive vehicle system. Okay, there are multiple ECUs we are going to use in car and heavy duty automotive vehicles and systems to operate the different features and controls multiple parameters in the automotive vehicles. In the automotive vehicles, there are n number of sensors and actuators we have fixed. And everything is going to controlled with help of the electronically controlled unit. So this system is having a closed loop control system. So this is going to monitor each and every functions what is happening in the automotive system or automotive vehicles. So this will always monitor and it will always get some data from the sensors. And whenever there is a variation in the data, because already we are going to have some the fixed and targeted data, the data is going to already programmed in the microprocessor, so that is called as a ECU. So when there is a variation in that current data and the already programmed data, so we are going to have some signals. That signal is going to receive with ECU, then ECU again received, and the ECU will compare both the data, and then ECU gives some signals to the give some commands to the actuators, and the actuator is going to rectify the problems. So this is what actually happened in ECU equipped cars. So quite simply, ECU is a device that controls all the electronic features. What are all the electronic feature is going to fit in the car. So this is going to controls all the electronic features in a car. So this may range from fuel injection to maintaining a perfect cabin temperature to control braking and suspension. And some vehicles have multiple ECU, as I said earlier, controlling different features, while some have single one controlling everything. Okay, there are different types of ECUs are there, and different types of sensors and actuators are also available. Okay, now so this is a electronic control unit. Some of the definition. So this is also known as a powertrain control module or engine control module. This is one of the type of electronic control unit, and this is going to determine the amount of fuel, ignition timing, and other parameters. An internal combustion engines, and it needs to keep running. So it does this by reading values from multi-dimensional maps, which contains values that is calculated by sensor devices monitoring the engine. The types of ECU, the types of ECU. So that there are different types of ECUs are with vehicles having multiple ECU. So they are divided on what task that is going to perform, and some of the types of ECUs we will discuss now. So the engine control module. So with its sensors, the EC electronic control module ensures the amount of fuel and ignition timing necessary to get the most power and economy out of the engine. So this is engine control module. And next thing is brake control module. So we are having a separate control module for braking system also. So this is also used in vehicles with equipped ABS, anti-lock braking system. So this BCM, brake control module, makes sure that the wheels are not skidding and determine when to trigger braking and let go of the brake to ensure the wheels do not lock up. So this is the another module, another electronic control module. So this is called as brake control module. So this will taken care of the braking system in ABS of the automotive vehicles. Next is the transmission control module, and this transmission TCM is mostly used on an automatic vehicle, and this TCM is going to ensure get smoothest shift if possible by assessing the engine RPM and acceleration of the car. And next is the telematic control module. Another one with the same abbreviations. This TCU ensures the car onboard services are up and running. It controls. Someone is again join and going. Okay, this telematic control module controls the satellite navigation and internet and phone connectivity of the vehicle. Okay, the suspension control module in present cars, the active suspension system. The present cars, most of the present car have the active suspension system. This suspension control module going to ensures the correct ride height and optimal changes to suspension. So depending upon the various driving conditions of your vehicle. Okay, and next is so the main working of ECU before
Hello,
enter into
viewers.
this ECU. So now you
Let's
have a
talk about
small
engine
introduction
control
of
module
the
and its
electronic
requirement in vehicles.
control
Basically,
module
engine control module is
through the
known as
video. You just
powertrain
watch this
control
video for
module
4
or
minutes.
engine control unit. So what the ECM does. The main function of this controller is to get information from sensors and run certain actuator. The vehicle computer uses these inputs to adjust its settings so the vehicle can run in accordance with your driving habit. Let's know about the connecting sensors, which are playing the important role in ECM. Engine coolant temperature sensor, air temperature sensor, manifold absolute pressure sensor, mass airflow sensor, idle air controller, crankshaft sensor, camshaft sensor, throttle position sensor, oxygen sensor, NOx sensor, engine coolant temperature sensor. Its function is to instruct radiator fan to turn on and cooling down the liquid after getting temperature above 75 degrees. It is usually located at the bottom of radiator or top radiator hose towards engine block. Air temperature sensor. Air temperature sensor monitors the temperature of air entering into engine. The ECM needs this information to estimate the air density and can prepare a balanced air mixture. It is usually located in air filter box or pipe that is attached to the air filter box. Manifold absolute pressure sensor. This sensor is a key sensor because it senses the engine load. This sensor measures air pressure, which tells ECM the current altitude of the vehicle. With the help of this information, ECM can adjust the ignition timing and fuel enhancement. It is bolted on the intake manifold or linked with a vacuum pipe from intake manifold. Mass airflow sensor. This type of sensor measures the volume of air entering into engine. Actually, this information helps the ECM to balance and deliver the correct fuel mass to the engine. It produces more current to keep temperature required by the manufacturer. It is located on air cleaner box. Idle air controller. It works to keep RPM of engine steady. It is an actuator, not a sensor. It increases the RPM of car until the coolant temperature sensor indicates the high engine temperature. Crankshaft sensor. It monitors the position and rotational speed of crankshaft, and this information is important for ECM to control ignition system timing. Camshaft sensor. It is an electromagnetic sensor which produces voltage when a metal object moves past it. The sensor contacts with ECM for position of camshaft. It is fixed at the end of camshaft, throttle position sensor. This sensor is linked with accelerator pedal and the throttle body, sends information about injector pulse width and spark timing. It is located in throttle body and it is neither washable nor repairable. Oxygen sensor. It measures the proportion of oxygen in fuel and the amount of fuel consumed by the engine. There are two types of oxygen sensors. One is zirconia and another one is titania. NOx sensor. This sensor contains a crystal that detects mechanical stress and produces a voltage when the car knocks. It also allows different grade fuel without any type of engine problem and it is fixed in engine body. These are the sensor details. But question is what happens when any sensor fails? Well, sometimes sensors simply don't work. So don't forget to repair it. Make sure to repair it or replace it with a new one for better performance. Have a safe drive.
So guys, I think you have seen the different types of sensors which is used in the automotive vehicle systems and the functions of the various sensors also have seen. So now we just enter into the working of ECU. The working of an ECU is actually not complicated and as one might assume. So it is an electronic device, so which has base numbers and parameters. So this will be filled in its memory. So because we are going to use a microprocessor or microcontroller, so depends upon the vehicle cost as well as the vehicle features. So we are going to using various devices in that. So we have the microprocessor or microcontroller. So here we are going to save a base numbers and parameters. So this is going to filled in its with the memory, and with multiple sensors around the vehicle feeding the ECU data, it can manage and control the electronic system efficiently by giving orders to improve their output. Okay, let us take an example of how the ECU controls something by looking at how airbags are deployed during an accident. Okay, the car has sensors located around itself called the crash sensor, which inform the ECU when a crash has occurred. So the ECU then measures the speed of the vehicle when it undergoes accident and then using its onboard memory compares the data of whether it should launch the airbags or not. So if the data provides enough reasons, the ECU deploys the airbags. Note that all this happens in more milliseconds. Okay, within a milliseconds, so this will happen. So otherwise, the passenger is going to have more injury. So some cases, the passenger is going to always. Some cases, the passenger is may have chance to die. Okay, because of this accident, if it is not working within a milliseconds or okay, that covers how the ECU works. Let's take the look what happens if it's faulty, when even worse when it breaks down. Okay, so the EC is going to taken care of all the features, all the electronic related features. Okay, this will always monitor and it always control. For example, the control of fuel injections. So it depends upon the various speeds and load conditions of the vehicle, automotive vehicles. So this EC is going to send the fuel flow and it will also varies the fuel flow rate to the intake manifold, as well as airflow rate is also going to vary depends upon the vehicle speed and load conditions, because it is going to always monitor the entire functions engine and the entire electronic components, as well as the control of ignition timing. So the spark ignition, okay, we are having a spark ignition engine, so this is also called as a petrol engine. So this is one type of engine classified in IC engines, internal combustion engines. Okay, in a spark ignition engine, so the spark timing is very much important. So depends upon the various speeds and load conditions of our vehicle, and based on the desires of the drivers and how the driver is going to drive the vehicle. So depends upon that the spark timing always timing also needs to change. If it is not change means, so definitely we will face a lot of consequences. So we will have the abnormal combustions and incomplete combustion process will happen the combustion chamber. Okay, so that the electronic control have the doing enormous work, and it will have the fantastic work in the most of the areas of the automotive vehicles. So it is concentrated in all the areas in the cars.
Hello.
And the common rail and the pressure sensors. Okay, the common rail, because so we are having a common rail direct injection system. So in the common rail we are going to maintain a constant pressure. The high pressurized fuel is going to stored in the common rail. From that common rail, the each and every fuel injector is going to connected. And when they turn, the turn is nothing but when the suction stroke is should come to the engine. So this common rail is going to give a fuel supply to the intake manifold or on the cylinder head. Okay, because most of the engines now have a separate or individual fuel injector system. So in olden days only, so we have had been used the throttle body fuel injection system. Okay, so now we are using the individual fuel injector system for each and every cylinder. Okay, the term common rail is going to refers to that all of the fuel injectors are supplied by a common fuel rail, which is nothing more than a pressure accumulator, where the fuel is going to stored at a high pressure. So this accumulator is going to supply multiple fuel injectors with high pressure fuel, and this is a fuel injection system. So the electronic fuel injection uses various engine sensors and control module to regulate the opening and closing of injector valves. The fuel delivery system, air induction system, okay, and computer control system. So the fuel system using anti-surge tank, because basically the fuel is in four wheelers and heavy motor vehicles, heavy duty vehicles. The fuel is going to collected from the fuel pump. The fuel pump may be in some of the place, but this that place is not relevant to the engines. That is not nearby to the engine. So we want to have a fuel from electronic fuel injection pump we need. After that, the fuel electronic fuel injection pump is going to pump the fuel from the fuel tank. That fuel is going to pass through the filter, the electronic fuel injection filter. So filter is going to collecting the unwanted things, and some of the sediments or some of the unwanted particles may be present in the fuel, that is going to collected in the electronic fuel injection filter, and then that will pass through the common rail. In common rail, the high pressure is the fuel is going to maintained within the common rail system. So when the train of the fuel injector is going to come, the fuel injector is going to immediately deliver the fuel. The amount or quantity of fuel is going to record for the suction stroke. So definitely it will send it to, because everything is going to, as I said earlier, and again. So everything is going to monitored by ECU, electronic control unit. So we will have the some of the firing order or spark timing order and fuel injection order. Okay, when the depends upon the crank rotation. Okay, each and every crank rotation. So we are going to supplying the, because we will have a crank position sensor. So when the crank is at top, so what is the degree angle, and when the crank is at the bottom. Okay, based on the piston movement, when the piston is movement, when the piston is going to reach nearly top dead center, so what is the angle of the crank. So it depends upon that. So we are going to fixing when we want to uh, deliver the fuel at right time. Okay, and when we want to ignite the spark at right time. So depends upon this. So we are going to note everything, and we are going to timely deliver the fuel injection as well as the spark. Okay, so this is what happened with the help of the sensors what we are going to using in automotive system. And that sensor is going to monitor by the electronic control unit, and the electronic control unit will come into the actuators. Here the actuator is nothing but a fuel injector. Okay, the sensor is nothing but a crank position sensor. So the actuator will do what the ECU is going to tell. Okay, so whenever there is a problem, the sensor is ECU is going to send commands to the actuators. So here the actuator is a fuel injectors. When you want excess fuel, so immediately it will send excess fuel. When you want less fuel, immediately it will send commands to allow less fuel. So this is what happens. So based on the commands given by the electronic control unit or module. Okay. The next is a fuel delivery system. Okay, the fuel delivery systems, as I said earlier, we are using electrical and electronic fuel pumps. So that will draw the fuel from the fuel tank and forces into the regulator. There are different types of fuel pumps we are using, and we are using a pressure regulator, so to control some amount of pressures that is going to enter into the fuel injectors, and as well as extra fuel is going to return to the fuel tank. So these are all the system we will have in the fuel injection system. Fuel pump, pressure regulator, and fuel injector is a simple coil or solenoid operator valve, as we seen in the previous class. So this fuel injector is also going to control with help of the ECU electronic control unit, because here we are using a solenoid operated valve. So this will do what the ECU will send. Okay, depends upon the commands what we are going to send it. So based on that, it will work. And injector pulse with this will indicate the time each injector is going to energize. And these are all the sensor system. So there are so many sensors we are using, and each and every sensor is going to given some number. Okay, so this will be monitored always with help of the electronic control module or electronic control device. Okay. uh, so because here we are having a computer, because electronic control unit or modules, what we are having microprocessor system. So that is also called as a computer. So this will always monitor the engine operating condition and reports this information. It is act like a spy. Okay, this will always monitor the functions of all the elements which is going to present in the automotive system. So this will always monitor, and when there is any mistake or when there is any misfunction or malfunction is going to happen in the automotive system, so this will immediately collect the information and immediately send it to the electronic control unit or module. Okay, the sensors or electrical devices that changes resistance or voltage with change in conditions such as temperature, pressure, and position. Based on the resistance or voltage change, so this will be considered as a signal, so that is going to transfer to the ECU when there is not constant voltage. Okay, so definitely we will have some signals. So the ECU will identify the data what the sensor is going to give, and depends upon the variation in the voltage or resistance. So ECU will identify, oh, so some cases the temperature may rise or some pressure may decrease. Some cases the pressure may rise, pressure may be decreased, and the crank positions may be in some of the misaligned angle. So this will also tell to the ECU. And this is engine sensor. The oxygen sensor measures the oxygen content in engine exhaust, because the main functions of the oxygen sensor is going to uh, measures the oxygen content, how much amount of oxygen's content in the engine exhaust. So this will be monitored. And next is this will also uh, excuse me. Okay, guys. Okay, now let us discuss the oxygen sensor. This oxygen sensor is going to measure the oxygen content in engine exhaust. So one of the most important sensors in most of the modern cars is the oxygen sensors, and this is also known as shortly it is also known as O2 sensor, because O2 is a chemical formula for oxygen, because this is known by everyone. And the oxygen sensor is going to monitor how much unburned oxygen is present, how much unburned oxygens, because this is going to filter in the exhaust. In exhaust, we can easily identify how much amount of unburned oxygen is present in the exhaust, as exhaust exists in the engine. So by monitoring the oxygen levels, the sensor is going to provide some means of measuring fuel mixture. Okay, the O2 sensor lets the computer know if the fuel mixture is burning rich, not enough oxygens, or lean, too much oxygens. Knows the ratio of fuel to air, and that will allow your vehicle's engine to take necessary changes to ensure that your car runs like it should. So this is the important purpose of using the oxygen sensor. Next is engine sensor. Okay, the throttle position sensors. So because when you are going to pressing the accelerator in your hand or rotating in your hand, or when you are going to pressing the accelerator pedal with your foot, okay, the angle of the throttle position is going to noted. Okay, the angle of the throttle position is going to noted. The data is going to given to the send it to the ECU. Okay, the data is going to be sent to the ECU. The throttle position sensor is a sensor that will be used to monitor the air intake of an engine and air fuel of engine. The sensor is easily located on the butterfly spindle shaft so that it can directly monitor the positions of the throttle and more advancement forms of the sensor are also used. So, for example, an extra closed throttle position sensors. So, this is shortly called as CTPS, and it may be applied to indicate that a throttle is completely closed. Some of the engine control units also controls the throttle position. Electronic throttle controls or drive by wire system, and if that is done, the position sensor is used to feedback loop up that enable. And then engine temperature sensors, you know very well this engine temperature sensor, why we are using this engine temperature sensor, and what is the need and purpose of the temperature sensor. Okay, the temperature basically the commonly, you know, the temperature sensor is going to identify the temperature or monitor the temperature in your automotive vehicles. Okay, how much amount of heat is developed by the engine, and what is the whether it is normal temperature is going to maintain, the constant temperature is going to maintain or not. So this will be monitored continuously, and when there is a very hike in temperature, so this will immediately give signals to the ECU, and we may have some extra or forced coolant systems to cool the engine. So this is an important purpose. The coolant temperature sensor, also known as ECT sensor, the engine coolant temperature sensor, and this is used to measure the temperature of the coolant and cooling system of an IC engines. Okay, the mass airflow sensors. So this is going to measure the amount of airflow in the engine, measures amount of outside air entering into the engine, and this will also contains an air flap or door that operates a variable resistors, and this will also helps how much amount of fuel is going to needed based on the air quantity and airflow rate into the intake manifold. Okay, depends upon that it will work. And engine sensor, the inlet air temperature is going to monitor, because too much amount of inlet when too much amount of inlet air temperature is going to enter into the inlet intake manifold, those that is also one of the major drawback of the incomplete combustion, because too much amount of heat is going to make evaporate of the petrol. Okay, so the we will have to maintain a constant inlet temperature. Okay, so that we are using inlet temperature sensor, so this will measure the temperature of air entering into the engine. Okay, and this is a crankshaft position sensor, so this is going to monitor the crankshaft positions in angle, so this will also detect the engine speed and changes in injector timing and the duration. So the higher engine speed is going to more fuel. So based on this will give signals to the ECU, and that is going to give. And then this is a throttle body sensor. This will use one or two fuel injectors. So this injector sprays fuel into the top of the throttle body air horn. So the main function is that the atomizer fuel mixes with air and drawn into the engine. So the fuel pressure regulator is going to spring loader and is a part of the housing. So in this, the fuel is going being injected whenever the engine is running, also called the continuous injection system. So this is the electronic fuel injection multi-port injection system. Okay, the multi-port fuel injection system. So the electronic fuel injection multi-port fuel injection system, the injector is going to pressure into the runner, the in the intake manifold. Here also the injector is going to spray towards an engine intake valve, because we have fixed this injector in directly at top of the or nearby to the intake valve. So each cylinder has its own fuel injectors. For example, if you are going to using a 4 number of cylinders or 5 number of cylinders, each and every cylinder have a different separate fuel injectors. So here the EFI, the direct fuel injection system. So these injectors are pressed into the combustion chamber and fuel spray directly into the combustion chamber. And this is some of the schematic representation of the electronic fuel injection system of the multi-port fuel injection system, multi-point fuel injection system. So here you just see the fuel supply from the fuel tank to the fuel line. Here we are using a fuel pump with high pressure. So we are using electrical and electronics combined fuel injection pump. So that is going to help us to pump the fuel. That will helpful to pump the fuel from the fuel tank. So next pumping of the fuel from the fuel tank, or the next the fuel is going to pass through the fuel filter. So this will filter all the unwanted things present in the fuels, and then this is going to pass through the fuel rail or common rail. So here we will maintain fuel at high pressure, and we will have a separate fuel injectors. Okay, we are also maintaining a fuel pressure regulators, so we should not enter very high pressure or low pressure. So we will, for regulating the fuel pressure, so we are using this fuel pressure regulator, and the excess amount of fuel is going to return to the fuel tank. So this is one of the closed loop system. So here also we are having a electronically controlled fuel injectors. Okay, so everything is going to controlled by electronic control unit. Okay guys, I think so this is enough.